Hello chemistry students, welcome back. I just wanted to film a short video that will give you some of the basics on acids and bases and pH and pOH scales, because you will need to know a little bit more about them than you've been taught so far in order to succeed in chemistry. So we're going to start with some simplified definitions. These definitions won't hold perfectly as we go forward. We'll get some more detailed definitions of what is defined as an acid and what is defined as a base a bit later on. But for the purpose of this video, we're simply going to define an acid as a chemical compound that releases H+ ions in aqueous solution when it's dissolved. And we'll define a base as a chemical compound that releases OH- ions into aqueous solution. So you all are probably at this point very familiar with the pH scale as a way of defining acids and bases. You guys have seen all of this before. So the pH scale, what we've typically seen before, is that it runs 0 through 14, and things that are low on the pH scale are acidic, and things that are high on the pH scale are basic. And right in the middle at 7, we have neutral water. So we need to go in a bit more detail than that, because we need to start quantifying what is happening with an acid or a base in terms of this release of H+ ions or this release of OH- ions, depending on whether we're talking about an acid or a base. So the first thing to understand is that the pH is a log scale. What a log scale is that the difference between any two numbers on this scale indicates a change of a tenfold increase in the concentration of H+ ions. So the difference between pH 5 and pH 6 is that a pH of 5 has 10 times as much H+ ions as a solution with pH of 6. And a solution with pH of 4 has 100 times the concentration of H+ as something with a pH of 6. So every jump between a number on the pH scale represents a tenfold increase. The difference between 6 and 5 is 10. The difference between 6 and 4 is 100. The difference between 6 and 3 is 1,000. And that comes from what the definition of pH is in terms of an equation. So if we're going to describe pH in the form of an equation, we would say that pH is equal to the negative log of the concentration of H+. So if your concentration of H+ for a solution is 1.0 times 10 to the negative 6, what that means is we're looking at this exponent and we're going to take the negative of it. We're looking for an exponent in base 10, and we're going to take the negative of what this exponent is, and that will tell us what the pH is. So a concentration of H+ of 1 times 10 to the negative 6 would equal a pH of 6. Looking at this exponent, taking the negative of it is all that we're doing there in order to estimate pH. So this answers probably a long-standing question that many of you had, which is, okay, well, if the pH is a scale of acidity, why are the lower numbers more acidic than the higher numbers? And that's because as you get a higher concentration of H+, you're going to become more acidic. So if instead we have a solution that has an H+ concentration of 1 times 10 to the negative 1, this solution has more H+ ions than this solution. The concentration of H+ is higher. This is equal to 0.1, whereas this is equal to 0.0000001. So this has a higher concentration of H+, that means it's more acidic. But if we look at this exponent, this would indicate that our pH would be 1. We just take the negative of what this exponent is. So this solution is more strongly acidic because it contains more H+ ions, but the pH value is lower because of the way that the log scale is measured, because it's the negative log of the concentration of H+. So what we're going to introduce here today is a new scale to go along with the pH scale, which is the pOH scale, which is a measure of the concentration of OH minus ions. So this is a scale that corresponds to the strength of a base. And what I've shown you on this scale is that the pOH values, a pOH scale can run right along a pH scale, and the values of pOH correspond directly to values of pH, but the scale runs in reverse. For example, if we have a solution that has a pH of 8, the corresponding value on the pOH scale would be a value of 6. So pH of 8, a solution with pH of 8 also has a pOH value of 6. Similarly, a solution with pH of 9 would have a pOH value of 5. And the pOH is measured in the same way as the pH, and that the pOH is the negative log of the concentration of OH minus. So the lower the number on this scale, the more concentrated of OH minus that you have in your solution, and the stronger your base is. So this side of the scale, on both the pH scale and the pOH scale, indicates bases, and this side of the scale indicates acids. So we would consider a solution with a pH of 3 to be acidic. That solution would also have a pOH of 11. A solution with a pOH of 11 would be considered to be acidic as well. So the question is, why do we care so much about H plus and OH minus? Why do we have an entire branch of chemistry devoted to taking a look at just these two ions? And the answer is, we care about them because these ions are created when water dissociates, and we know that water is probably the most important chemical that we deal with on a regular basis. So water has a specific dissociation constant, and when water dissociates, it falls apart into H plus ions and OH minus ions. So the reason we care so much about H plus and OH minus is they are the components that make up water. So the dissociation constant of water has a specific value, and that's 1 times 10 to the negative 14. Dissociation constants are calculated by multiplying the concentration of the two ions that make up the chemical together. So the dissociation constant of water is calculated by multiplying the concentration of H plus times the concentration of OH minus. So this dissociation constant of water value will not change. So when you multiply the concentration of H plus and the concentration of OH minus in a solution together, you will always end up getting 1 times 10 to the negative 14. So when we are at neutral pH, that means that our H plus and OH minus concentrations are balanced out. In water at neutral pH, you have the same concentration of H plus as OH minus. And since those have to multiply together to equal 10 to the negative 14, that indicates that the concentration of H plus would be 1 times 10 to the negative 7, and the concentration of OH minus would be the same. As we saw here on the log scale, if we just look at the negative exponent and take the negative of it, if we look at the negative exponent and we take the negative of it, that tells us what the corresponding pH and pOH values are. And that tells us that at a H plus concentration of 1 times 10 to the negative 7, that would give us a pH value of 7. And at a OH minus concentration of 10 to the negative 7, that would give us a pOH of also 7. So this 7 on our scale is neutral because it is when the concentration of H plus and OH minus are balanced. And the point is, as you increase the concentration of one of them, the other is going to have to decrease by a similar degree. So if you increase the concentration of H plus from 10 to the negative 7 to 10 to the negative 6, what will happen to the concentration of OH minus is it will decrease from 10 to the negative 7 to 10 to the negative 8. So these two things are balanced. As your concentration of H plus increases, your concentration of OH minus decreases by the same degree. and vice versa. So